So, we have finished bearing capacity, Meyerhoff's Terjagi's theory, Meyerhoff's analysis, also bearing capacity for modified bearing capacity for in case of strip footing, as well as gone to modified value for square, rectangular, settlement analysis, immediate and consolidation settlement analysis, stress below a point load, line load, strip load, rectangular loaded area, circular load. Then last part I have finished any shape, vertical stress of uniformly loaded area of any other shape other than point, strip, circular or rectangular. Now, before I go to the design of these foundations, let us solve few problems. So, example 1, this is the case, this is your 0, this is 1 meter, this is your 2, this is your 4, 12 meter. Subsoil investigation is up to 16 meter. Though I have not started the design, it has been from the design it has been said the foundation is resting at a depth 2 meter below the ground surface. Water table is located at 2 meter. So, the size of this foundation is your 2 meter by 2 meter. Load intensity is coming 450 kilonewton, and 0 to 1 meter is your filling or fill soil. Between 1 to 4 meter, 1 to 4 meter, this is soil 1 having grey silt clay, gamma is equal to 18 kilonewton per meter cube, Cu is equal to 40 kilonewton per meter square, Cc by 1 plus E0 is equal to 0.05. Then layer 2, its silt clay, gamma is equal to 18 kilonewton per meter cube, Cu is equal to 25 kilonewton per meter square, Cc by 1 plus E0 which is equal to 0.16. Layer 3, it is again bluish grey silt with conker, gamma is equal to 19 kilonewton per meter cube, Cu is equal to 60 kilonewton per meter square, Cc by 1 plus E0 which is equal to 0.10. So, from here let us find it out Q net. Q net is equal to 450 divided by 2 by 2 which is equal to 112.5 kilonewton per meter square, and the depth of the foundations is equal to 2 meter. So, bearing capacity, first one is your bearing capacity, you have to find it out NC, NC is equal to 5 into 1 plus 0.2 B by L into 1 plus 0.2 dF by B. These things earlier I have discussed with you. So, it comes out to be 7.2. So, what happened, it is 2 meter by 2 meter. If I put it, if this is my B, if I put it my failure envelope up to 2 times of B, 2 into 2, 4 meter. So, here it is 2 meter, here it is 2 meter, total will be, this will be your 4 meter. So, in that case, so as most of the, if you look at here, either you can take it weighted average of Cu1 and Cu2, because both these cases it is lying layer 1 as well as layer 2. In this case I am considering Cu is equal to 40 kilonewton per meter square. Generally if half part will be there, other half part will be there here, then it will be weighted average generally taken. Now Q ultimate is equal to CNC, so which is equal to 40 into 7.2, which is equal to 288 kilonewton per meter square. So factor of safety is equal to, factor of safety is your Q net is your 112 and Q ultimate by Q net, which is equal to 288 by 112.5, which is equal to 2.56, greater than 2.5, which is okay. Now come to your settlement calculations. In settlement, first one is your immediate settlement. In immediate settlement, what are the things given? Mu is equal to 0.5, IP center is equal to 1.12, E is equal to 600 Cu, which is equal to 19200 kilonewton per meter square. So Cu average, which is equal to 40 into 2 plus 25 into 2 by 4. 40 into 2, this 40, it is your 2 meter, then 25, this is your 2 meter. So that is why this average has been taken. This average is your 32 kilonewton per meter square. Now immediate settlement, immediate, which is equal to QNB by E into 1 minus mu square to IP, which is equal to 112.5 into 2 by 19200 into 0.75 into IP is 1.12, which is equal to 0.0098 meter. This is your immediate settlement. Now come to your consolidation settlement. Consolidation settlement. So you have to find it out P0 and delta P. So at A, because consolidation settlement you have to find it out at different point, at this point, at this point, because up to this it is effective. So consolidation settlement at point A, P0 is equal to 18 into 2.0 plus 8 into 1.0. Why 18 into 2.0? If you look at here, the complete soil. So this soil having, including this fill soil, gamma is 18. So water table is at 2 meter. If I come up to this, then what will happen? Up to 2 into this is your up to water table below, 18 is your gamma, then 8 into 1.0, 8 into 1.0 after 2, then at the middle, so it will be 2 meter, so at the middle 1 meter, so it will be 8 because gamma submerged is equal to gamma saturated minus gamma W. So, approximately I put it 18 minus 10 which is equal to 8. So, this will be 8 into 1 and that gives the value of 44 kilonewton per meter square. Now, delta P, there are two ways, either you can measure it by means of 2:1 distribution, or you can measure, because this is a square, this is a square, this shape is there, so this is a square. So, here it is a 2 meter, here it is 2 meter. So, what will happen at the center? Then in that case you make it into 4 parts as I have discussed earlier. Increase in stress at a depth below the footing 1 meter. What is your increase in stress? That delta P comes out to be 67.5 kilonewton per meter square. At point B, that means here if I put it A, this is A, this will be B. At point B, P0 is equal to 18 into 2 plus 8 into 2 plus 8 into 1.0, which is equal to 60 kilonewton per meter square. 18 into 2 up to here, because water table is here, gamma is 18, 18 into 2 plus 8 into, here it is 2 meter, 8 is your submerged unit weight into 2, here it will be up to 2 meter, then 1 meter will be there at the center, again it is 18. So, 18 minus 10, then it will be 8 into 1. So, similarly you can find it out delta P, which is equal to 16.9 kilonewton per meter square. So, consolidation settlement is equal to Cc by 1 plus E0 H log 10 P0 plus delta P by P0, because there are two terms. So, it will be 0.05 into 2 is your this, then log 10 44 plus 67.5 by 44 plus 0.16 into 2 log 10, 60 plus 16.9 divided by 60, which is equal to 0.075. Now, total settlement, which is equal to immediate plus consolidations, which is equal to 0.0098 plus 0.075. This is your final settlement. So, in this case, let me repeat what I have done. This is your subsoil profile is there, and foundation size has been already decided. This will come from our design. It will be continuing after this examples are over. The foundation size are 2 meter by 2 meter, and it rested below a ground surface of 2 meter below the ground surface, acted upon by load intensity of 450 kilonewton. There are 3 layers. Layer 1 having grey silt clay, gamma is given, Cu is given, and Cc by 1 plus E0 also given. second layer is your silty clay, third layer also grey silt. In this case what happen, once foundation is putting there, general effect we see it, if this is my B, so the effect will be 2B. So, if once it is 2 meter, it will be extended up to 4 meter. So, that means this is your 2 meter and this is your 2 meter. So, load intensity has been calculated, load divided by area of the foundation, this is your load intensity, and bearing capacity also calculated. From there factor of safety also I calculated, factor of safety Q ultimate by Q net. Then immediate settlement as well as consolidation settlement has been calculated. For immediate settlement, CU average has been considered because two layers are there, 40 into 2 plus 25 into 2 divided by total is your 4. So, that is your 32 kilonewton per meter square. And for consolidation settlement, 2 points has been considered at the center, this layer at the center A, this layer at the center B up to this height. Then increase in stress because this is a square. So, this is square and it is at the middle below this Z depth, this is your Z. Then what will happen if this is my depth below this Z, what will happen below this at the center. So, how I have calculated, make into approximately square. So, then this is 1, this is 2, this is 3 and this will be 4. This will be exactly at the corner. Then increase in stress has been calculated as 67.5 for case 1. Case 2 it is 16.9 kilonewton per meter square. So, consolidation settlement comes out to be 0.075 meter, which is your 75 mm. Here it is your 9.8 mm. So, add it 84 point something mm is your consolidation settlement. This is the calculation of your bearing capacity. Next example, example 2, this is what given. This is your 0, this is 2, this is your 12 meter and there is a footing here. This is your 2.5 meter, gamma is your 18 kilonewton per meter cube and the profile is given, n value profile is given, SPT n 0, 10, 20 and this is your 30 SPT n. So, it comes out to be n average which is equal to your 15. Now, once it is a 2.5 meter, so what will happen? Pressure intensity will be up to a depth of 5 meter, up to a depth of 5 meter. So, this is where at a depth 2.5 where we are interested to find it out. So, that means if this is your 5 meter, so 2 meter is there, then it will be 7 meter below there. So, what is given here? N average is your 15. Once you know the n average value, then from the n average you are supposed to get the value of phi is equal to 34 degree. Once phi is equal to 34 degree, what does it mean? Basically it is neither general shear failure. So, local shear failure phi is greater than equal to 28 degree, general shear failure phi is 28 degree to phi is equal to 36 degree. So, you have to do the interpolations. By doing, I have explained also these interpolations earlier. By doing these interpolations, you will find it out phi is equal to 34 degree, NQ is equal to 30 degree, N gamma is equal to 41, sorry it is not degree, NQ is equal to 30, N gamma is equal to 41, then your Q net is equal to how much is your load intensity? Load intensity is coming out to be, it comes 1500 kilonewton. So, net load intensity will be 1500 divided by 2.5 by 2.5, which is equal to your 240 kilonewton per meter square. So, what is your ultimate bearing capacity? Ultimate bearing capacity Q ultimate, because it is rectangular, 1.3 CNC plus 0.4 gamma B N gamma, sorry it is a square, 1.3 CNC B gamma plus gamma DF NQ. You can calculate from here. Then you can calculate your factor of safety, which is greater than 2.5. Then you go for your settlement. Because this is a sandy soil, for sandy soil what is your settlement, consolidation settlement? 2.3 P0 by E H log 10 P0 plus delta P by P0. So, P0 will be 18 into 2 plus 9 into 2.5, 18 into 2, here is also water table, 18 into 2 and below this, so it will be 8 or 9 depending upon 18 into minus 9.81 depending upon that. So, you are calculating your P0. Now, calculate your delta P. So, delta P again same thing you can calculate, this is 2.5 and this is your 2.5 at the center. So, put it, so it become a corner at a depth of here 2.5, depth of is your also 2.5. You can very easily calculate your delta P. So, delta P comes out to be 84 kilonewton per meter square. Here it is your 58.5 kilonewton per meter square. So, based on this N value, E can be calculated C1 plus C2 N. C1 is your 39 plus C2 is your 4.5 into N average is your 15, which is equal to 1065 kg per cm square, which is equal to 10650 kilonewton per meter square. So, based on this, rho C calculated 24 mm. So, if you look at this example 2, now there is a subsoil profile, water table is located at 2 meter depth and foundation size is 2.5 meter by 2.5 meter, resting on sandy soil below a depth of 2 meter below the ground surface, gamma is given and other parameters have not been given, only parameter is given N values up to different depth. From there you can calculate what is the N average is coming out to be 15. Once you know the N average, from N average you calculate the value of your phi. Now it is neither general shear failure or local shear failure. So, sorry, it is less than equal to 28 degree. Neither it is general shear failure or local shear failure, it is in between. So, interpolation has to be done and has been carried out. Based on that, based on the value of phi is equal to 34 degree, NQ is equal to 30, N gamma is equal to 41. So, Q net is equal to 240 kilonewton per meter square. So, based on that you calculate your Q ultimate value, 1.3 CNC, 0.4 gamma B N gamma plus gamma DF NQ. NQ and N gamma is there because there is no term of C, this can be 0. Then you can calculate factor of safety, it should be come out greater than 2.5. Then find it out settlement. Settlement is your 2.3 P0 by E H log 10 P0 plus delta P by P0. So, P0 is 18 into 2, here is your water table. So, 18 minus 10, that is your 8, up to, you have to find it out up to here center. So, this will be your 2.5. So, this comes out to be 58.5 kilonewton per meter square. And delta P, how we have calculated? This is a square shape 2.5 by 2.5 at the middle. I divided into 4 parts, 1, 2, 3 and 4, 1, 2, 3, 4, and at the corner, rectangular loaded area at the corner, add it. So, delta P is your 84 kilonewton per meter square. You have to calculate E C1 plus C2n. C1 is your 39, C2 is equal to 4.5 kg per cm square. So, it comes out to be 1065 kg per cm square. E is equal to 10650 kilonewton per meter square. From there we calculate rho C is equal to 24 mm. I will solve 2 more examples maybe next class, I will keep it here. Thank you.